I think you already know from previous classes what the words parallel and perpendicular mean, but we're going to look a little bit more specifically at how that plays out in algebra class in terms of slopes. So if two lines are parallel, you know that that means that they never run into each other. And if you think about that, that means they're kind of on the same angle. And the angle that a line is on is determined by its slope. So if two lines are parallel, the only way that could happen is if they have exactly the same slope. So some facts we want to think about parallel lines. Two distinct lines in the coordinate plane either intersect or are parallel. In other words, two lines either run into each other or they never run into each other. All right, parallel lines are lines in the same plane that never intersect. So that's sort of the definition of parallel lines. Non-vertical lines are parallel if they have the same slope and different y-intercepts. Okay, so non-vertical is important, right? Remember, lines that are vertical don't have a slope. So we can't say that they have the same slope because they don't have one. But what they do have in common is that neither of them has a slope. So that does make them both vertical. So they'd still be parallel. Vertical lines are parallel if they have different x-intercepts. All right, so let's take a look at the first example using this fact. A line passes through the point 12, 5 and is parallel to the graph of y equals 2/3 x minus 1. Now, I'm going to draw you a quick sketch so you can envision the situation, but you won't need to draw a sketch when you're doing the problem. So I'm going to do it off to the side. So if I imagine the line that starts at -1 and kind of goes up 2 and over 3, it's going to look, whoa, that was just terrible. Let me try that again. It's going to look something like that, right? I'm going through 0, -1, and I go up 2 and over 3. Now, there's a point, 12, 5, so it's like way over here. And I know that that line is parallel to this one, so it's going to look something like that. So if I think about it, I know two things. I know that it goes through the point 12, 5, and I know that it has a slope the same as this one. So I know that the slope is 2/3. Okay, well, we know how to write point-slope equations when we know a point and a slope. So let's put that to work. If I do y minus y1 equals m times x minus x1, I put in the x I know for x1, and I put in the y I know for y1. Then these slopes have to be the same. So I take out my m and I put in 2/3 for the slope. I'm like, great, I wrote my equation, except I read the directions carefully and I go, wait a minute. They want slope-intercept form. That doesn't mean I did anything wrong. It just means I'm not done. So remember what we were practicing with converting between forms. If I have a couple choices. I could clear the fraction, or I can check and see if distributing the fraction wouldn't be so bad. So 2/3 times x is no big deal. That's just 2/3 x. And notice 12 happens to be divisible by 3. So distributing this fraction really wouldn't be that bad. So personally, that's what I would do. Y minus 5 equals 2/3 x. Now, in case you're having trouble with multiplying the fraction by the whole number, remember 2/3 times -12 is like times -12 over 1. So we look at that and we're like, okay, 12 divided by 3 is 4. 2 times -4 is -8. 1 times 1 is 1. So this is just really -8. Now, that still doesn't look like slope-intercept form. Remember, slope-intercept is y equals mx plus b. But we're awful close. If we just add this 5 to each side, we'll have what we're looking for. Y equals 2/3 x minus 3. All right, now let's talk about perpendicular lines. I think you're probably pretty familiar with those as well, given how common they are in everyday life. Remember, lines are perpendicular if when they meet, they form 4 right angles. Two non-vertical lines are perpendicular if the product of their slopes is -1. Okay, that's not always like really obvious to people. But saying that their slopes are opposite reciprocals is usually a little bit easier. So if the slope is one of them is a over b, the slope of the one that's perpendicular to it, that's the symbol for perpendicular, will be -b over a. Remember, reciprocal means to flip the fraction over, and opposite means to change the sign. So we're going to be able to make use of that fact, kind of like we made use of the fact that parallel lines had the same slopes. All right, write the equation of the line that passes through 1, 8 and is perpendicular to the graph of y equals 2x plus 1. Okay, they gave us a point. So we're thinking point slope form again, right? Y minus y1 equals m times x minus x1. And we can go right at that point. We can take out x1 and put in a 1. We can take out y1 and put in an 8. But this all kind of screeches to a halt because the slope isn't 2, because these lines are not parallel. So the slope of the given line was 2. The slope of our perpendicular line needs to be the opposite reciprocal. So our slope was positive, so this slope will be negative. Our slope was 2, or 2 over 1. So if I flip that over, that's negative 1/2. So now I know that the slope I should be using is negative 1/2. And just like in the previous problem, they asked us for slope-intercept form. Again, we look to see, would distributing be so terrible? And it really wouldn't be. It's pretty easy multiplication. So we've got y minus 8 equals negative 1/2 x. A negative times a negative is a positive, and a half times 1 is just a half. All right, next. I need y to be all the way alone, so I've got to add 8 to each side. Now, this is a little bit more awkward, but it's not terrible. I'm just going to come over here so I have some extra space. I've got y equals negative 1/2 x. Now, let's not panic over that addition, right? We've got a half plus 8. We know we need a common denominator. Well, right now, this has a denominator of 2. That has a denominator of 1. Well, 1 times 2 is 2. So 8 times 2 is 16, plus the 1/2 is 17/2. So I'm going to add 17/2. That's our equation in slope-intercept form.